Bismillahirrahmanirrahim. In this video, I'll proceed with the discussion of exercise from 2.6.1 function. So let's look at the exercise 2. The function fx and gx are defined as below. So where k is a constant, find the expression in terms of k for the f inverse as well as f composite g. So what we have to do first here is we have function f, then we need to find out the inverse function. So we have here for the part A, fx given in terms of k as kx minus 3. And then we put this one as a y. So y is equivalent to fx. Therefore, y is equivalent to kx minus 3. We need to put x as a subject. Kx is equivalent to y plus 3. Therefore, x is equivalent to y plus 3 divided by k. Therefore, finally, the inverse function f is equals to x plus 3 over k. So this is the inverse function f in terms of k. And then the next one, we need to find out the composite function for the part 2. So for the composite function, f gx is equals to f. So we need to write down the inner function first. We have the function of g, which is x plus 2k. And we need to substitute x as x plus 2k inside the function f. So we have here f, which is k, and our x, we have to substitute with the x plus 2k and then minus 3. So expand the expression here, kx plus 2k squared minus 3. So we need to find out, this is our f composite g in terms of k. And then for the part B, we need to find out the possible values of k where given f composite g of x is equals to 7. So the answer is equals to 4. So this is for the part B, given f composite g when the x is 7. So the answer is equivalent to 4. And we already have the f composite g on the previous part in terms of k. So let us substitute 4 is equals to k. So substitute x with the 7. So 7 plus 2k squared minus 3. And at the end, we will get 2k squared plus 7k minus 7, and this one is equals to 0. So once we get in terms of quadratic like this, of course we can solve this quadratic. So there are three possibilities when you need to solve the any quadratic equation. So the first method, if it is possible for you to factorize, so we need to factorize. And then the second method is normally we will apply formula first before completing the square. So the second option, formula, and the third option by using completing the square. So normally, if the students have the quadratic equation which is impossible for you to have in terms of whole number or any integer, so normally they will just proceed or just use calculator to get the values of unknown. But what you have to do actually, we need to move to the next method, which is by using quadratic formula. So whatever answer given from your calculator is, that calculator give you the answer by using quadratic formula. So you need to show how can you apply the quadratic formula in order to get the unknown. So in this case, our unknown is k. Therefore, by using quadratic formula, so this is the quadratic formula. In general, x is equivalent to negative b plus minus b squared minus 4ac divided by 2a. So you need to memorize this quadratic formula. And if the question specifically mentioned for you to solve the quadratic equation by using completing the square, then you need to apply completing the square. So for this case, since we cannot factorize, normally we will just use quadratic formula, not just leave it the answer, not just give the answer, the final answer from your calculator. So by using quadratic formula, so our unknown here is k. So k is equivalent to negative 7, which is our b is 7. So negative 7 plus minus 7 squared minus 4a C divided by 2A. So A is 2. So from here you will calculate and you will get the values of K is negative 7 plus minus square root of 105, the whole thing divided by 4. So you need to make sure the values inside the square root in the simplest form. So for this case, we cannot simplify anymore for the square root of 105. So we just leave it like this. So this is the final answer for the K. So there are two values of K. One is the negative 7 plus square root of 105 over 4, and another one is negative 7 minus square root of 105 divided by 4, or you can just leave it like this. So it's okay. So it means that we do have two values of K. Okay, that's all for the exercise 2. You can you can proceed with your tutorial 1 part 2 on chapter 2.